Cisco Certified Network Associate Day 30. Welcome back everybody. I'm Imran Rafai, your trainer for this entire series. We are reaching the end of ICND 1, right? So we have discussed almost everything that is part of ICND 1. We have few topics that we have missed here and there. So what we're going to do is use this video and the next video to fill those gaps, right? So without wasting much time, let's get straight into today's class. But before we go ahead, I'm going to put in some social media contacts on our screens. Please feel free to visit us on Facebook. We have a YouTube channel which you're watching this from. Please subscribe to that. Twitter feeds, my personal social media contacts are there, and of course my email address is there displayed here. So please feel to write into us. So what are we going to do today? Today we're going to look into three topics. We're going to look at network architectures, we're going to look at network impacts, and we're going to also look at troubleshooting methodology. Cisco has two types of architectural approach. One is the Cisco three-tier architecture, and then we have something called as a collapsed layer architecture. This is the one that you see on the screen is called as the three-tier architecture because it has three different layers: the access layer, the distribution layer, and the core layer. So it has three different layers. Now, access layers are layers of devices which directly connects to end devices, right? So all these end devices that you have in your office, they all connect to the access layer switch. Now typically access layer switches are not very expensive switch. They're reasonably low powered switches, and all the devices, your switches, your computers, your laptops, your IP phones, all of them connect to these switches. Now these switches are not interconnected. So if you, let's say you have hundreds, like in each building will have maybe hundreds of switches, because every floor might have about 10 devices. You know, if you have too many computers on each floors, right, too many sockets on each floors. Now it's not only about computers. You might have meeting rooms with ports, right? These ports are all, you know, even if there are no computers connected, there are ports. These ports would all lead to your wiring closet, where you'll have a switch, and all the wires would be actually connected to those switches, right? So you'll have hundreds and hundreds of devices in each building. Now typically these access layer switches will not be connected to each other, because if you start connecting each of those devices to another device or another switch, you would have a huge mess, and it is going to be a wiring hell, right? So what what would be done is we would have another layer called the distribution layer, and we'll have a slightly more high powered device which could also do layer 3. So it will be like in access layer, these switches are a layer 2 switch. It cannot do layer 3. Distribution layer also will not do layer 3, but they're high powered devices, right? If access layer switches want to connect to another access layer switch, that will always go through the distribution layer and then come back to the access layer and communicate. That's how it would be done. Distribution layer, typically it's also called as the building distribution layer, because if, let's say, your campus has more than one building, each of those buildings will have one distribution layer, where all the access layer switches of that building would be wired to that distribution layer switch. And then you will have another layer, the core layer. Now core layer is typically where outside connections, right, to the internet or to your offsite VPN connections, all that gets terminated to your core layer, right? It's connected to your core layer. So core layer is your link to outside world, to layer 3 routing world, right? And distribution layer, like I said, if you have many buildings, each of those buildings will have one distribution layer, and then all those distribution layer devices would be connected to the core layer switch. Now core layer switches would be connected to each other, right? Like you see here. So typically the core layer switches would be connected to each other. We would connect an ether channel. Now what is ether channel? We will not discuss ether channel. We will be discussing more about ether channel in ICND 2, but just to give a brief introduction to Ether channel is where you will have multiple cables. Let's say in this case, let's assume there are two cables of 10 gigabit Ethernets, right? You have 10G links. Ether channel is where you combine these two 10G links to logically look like one 20G link, right? So you're going to use these speeds of both these links and combine them and have a 20G link between these two devices, right? So if you see none of the other layers, access layer or distribution layer, you do not have interconnection between devices, but core layer will be connected to each other, right? Now, why do we need a three-tiered approach? Now, typically three-tiered approach is there for easy troubleshooting. Now, you have troubleshooting one, and it's logically, the traffic is logically separated, right? Access layer, if you want devices in each network to communicate, it will communicate here, it will not go beyond. But if you want it to go from different flows, then the traffic would flow to a distribution layer switch and then come out and then go back to an access layer switch and then go to those devices. If you want to have communication between multiple buildings, then the traffic is always going to go to distribution, then to the core, and from core it is going to go to whichever core switch that it needs to go, and then it comes back to the distribution layer, then to your access layer, and back into those devices, right? So traffic management, distribution of traffic happens in a much logical way, easy for troubleshooting, and a much efficient way. Now, you might say your company is not that big, so you don't you don't have so much IT resource to allocate so many devices. So there is another approach known as the collapsed core, where these two layers, the core layer and distribution layer, gets combined, and this layer, this architecture is known as the collapsed core architecture, right? Where distribution layer and core layer devices are combined and it does one function. So you have access layer is connected directly to this collapsed core layer, and then again collapsed core layer devices are connected to each other, but access layers are not. And access layers, if it wants to communicate with another access layer switch, it has to go through the collapsed core layer switches and then comes back, so traffic is done. So this is another form of architecture which is much more efficient, right? So if you don't have the kind of money and the kind of resources, then collapsed core. But if you're working for a big organization and if they have the funding, then yes, three-tier architecture is definitely the way to go. Next, we look at network impacts. So according to ICND topics, these are the three devices that they want us to speak about. So firewall, we did not speak about firewall much because of course ICND, we don't need to speak about it. If you're looking at CCNA security, of course, yes, we will come back to firewalls. But what is a firewall? We did a little bit of traffic filtering using ACL in our last, I think, a couple of videos ago. But firewall is a device that is exclusively for packet filtering, right? So let's say you have a network, right? You have a network, and let's say there is a switch here, right? And then you have your router, and then these devices. Okay, now a firewall is a device, typically it sits before your it sits between your network and internet, right? This is the firewall, and what it does is it does not allow traffic to come in from a low security zone. So normally what happens is firewalls typically have two zones. One is called the inside zone and one is the outside zone. Typically the inside zone have security level of 100, which means it's very secure, and outside zone have security level of 0, which is least secure. As a rule, traffic going from high security zone to a low security zone is always allowed, but traffic coming from a low security zone to a high security zone would always be dropped. Now this is how traffic is. So let's say if your device is communicating from, let's say, from your computer, you're sending out a traffic to a ping traffic, for instance, to a device on the internet, right? So you're doing ping. The ping would reach them, right? So let's say you're doing ping. Normally what happens is when you try pinging, it will say ping timed out. But what's happening is the ping would go through, because it's going from high level to a low level. Your ping will go out, but on your way back, that ping is coming from a low security level to a high security level, and hence the ASA or any firewall would drop that packet, right? So when you're looking at your network, you need to analyze firewalls. Now, firewalls, not only the network firewalls that you have like ASA, even your computer will have firewalls which will not let. So you'll have customers call and say, you know what, my traffic is, my application is not working, or that person is trying to access a server. It says I cannot access that server. You need to look at firewalls. Firewalls always create havoc, because firewalls would block traffic. Even the software firewall that's sitting on the client's machine, that also could be stopping traffic. So you might have to go to that firewall and open that port saying any traffic going to this access, depending on, of course, depending on your organization's need for that software or that protocol. You need to, as an administrator, you'll have to go and open those ports on your computer or on your firewall, right? That's how firewalls can have network impact. Access point, again, access point and wireless controller. Now, what's an access point? Normally, in an organization, if it's a totally wired network where you don't have any wireless access points or wireless devices, it's going to be typically very secure, because people who have to access the network are going to be inside your organization, because you don't have a wire that's outside the building where any stranger can come in and plug the device. But with access point, wireless access point, that has changed. Your access point does not have a barrier limit. That means you plug an access point in your office, your access point can be actually accessed by anybody, right? If they have a password, if they can hack your password, crack your password. Now, I don't want to get into hacking of passwords and all those things, but let's assume you've forgotten to give a password. You've kept your access point open, wireless access point open, right? The SSID without a password. Anybody can literally, so if, let's say, there is a wireless access point here, right, and somebody, let's say a rogue is sitting, right, he gets access to, he has his device and he's connecting to your access point, and if your SSID is open, that person now has access to your network. Every shared file, every shared network, everything can be accessed. It's as if that person is come and he's sitting inside your office, right? So access points need to be well documented. It should be protected. You should know, and you need to, as a network administrator, you need to be careful that access points are protected. And even if it's not protected, make sure your access points are placed in such a way that you're not sending too much power outside the building for somebody else to get inside, right? So that's how access point. Now, what's wireless controller? If, let's say, you have hundreds of these access points in your organization, if you're talking about like regular home-based access points or wireless routers that you have in your house, you go configure your SSID and all your passwords individually on those machines. But in a big organization, that's not practical, because you might have hundreds of those devices, and if you want to, let's say your password gets compromised and you want to change that password, it's not practical for you to go to hundreds of those devices and change those passwords. You would do about 5 of them and you'll be tired. So what typically high-end access points and wireless controllers, access points, they run on wireless controllers, where you'll have a central wireless controller, right? And these wireless controllers are connected to your network, right? And these wireless controllers are connected to access points, right? You might have 100 access points and all of them are connected to the controller. And from the controller, you say SSID change, right? You change the SSID or password change, all of the devices get updated automatically. That's where wireless controllers uses. So you'll have one central wireless controller, and you might have hundreds of those devices. Make one change in your controller, the controller actually controls all these access points, or access points all of them, right? So instead of using standalone access points, it's always better to use wireless controller based access points, where you control your entire wireless network from one controller, and the controller will send those updates to the access points, which will then have the updated passwords and updated security features. Troubleshooting methodology. Now, if you worked in IT, backend, right, call centers, you would have people who call in and say, my computer's internet doesn't work. Now, when you finally get to them, you realize it was definitely not a problem with the internet, it was a problem with the software or any other thing. So when you're in networking now, this is what it is. You have to have a troubleshooting methodology, because you will keep getting calls from somebody who would say something, but then you cannot accept it, right? Like, for instance, most of the time in IT, you will have people who would call in and describe their problem in such a way as if the whole world is stopped, but then it could be a very, very trivial problem, right? So we need to have a troubleshooting methodology, and this is I think a methodology that is used by a lot of people, right? So as a thing, you need to first define the problem. So let's say somebody calls and says, my computer is not working. You need to, that's what their assumption is. That's a problem from the perspective of the customer, but you need to gather facts. Now you need to ask them question, why is it not working? Is the power on? Right? If the power is on, is your monitor on? Maybe the computer is on, maybe just the computer, maybe the monitor is off, right? I'm just giving, I know CCNA, we're talking about network more than anything, but here I'm talking about this troubleshooting methodology could be used for anything in life. So somebody's telling, my wireless is not working, or somebody says I cannot access a certain network. So as a network engineer, you need to gather facts. You need to gather facts and see what is going wrong. Is it going wrong? Or if, let's say, for instance, they say they cannot access the internet, is it at a particular time, or they cannot access it anytime? It could be a problem where some other device is interfering, right? So you need to identify, you need to get the facts. Also, you could ask them to check with their neighbor's computer, right? Or rather, the person who's sitting next to them. Just look at their computer. Ask them, is their computer working, or is their internet working? So try to gather as many facts as possible, because that is going to be very critical. If you're not gathering enough information, like I said, if the customer calls you and tells that the computer is not working, and you're assuming that the computer is faulty, that's wrong. You cannot assume anything. Maybe the switch is not on. They've forgotten to plug the computer on, or put the power on. So gather ask them questions as much as you want, and try to get the entire fact, right? Everything that's associated with that problem. And then, knowing, because you know more than those users, you know what could go wrong, right? So consider all the possibilities. What could have gone wrong? What can be done? Then create action plans. You will have plan A, plan B, plan C, right? This is what happens if you do plan A. This will happen if you do plan B. This is what happens if you do plan C. So try to implement your plans. Let's say, for instance, you have plan A. Like somebody said, there's a problem with internet network, and you realize it could be a problem with a cable. You go to your wiring closets and you swap those cables. Now, again, you might have more than one solutions. Don't do all the solutions and try to get try to fix the issue, because then you will not know what is the root cause. And as long as you don't know what the root cause is, it's going to be a big problem, because you could have a similar problem after a few days and you will not know what the root cause is. So implement one solution at a time and see if you have results. So implement the first solution, observe result. If it resolved, brilliant, document that. If it did not resolve, then you need to go back to define the problem again, or maybe to gather facts again, and again create an action plan and implement, right? So every time you implement, you need, once your problem is solved, you need to create a document of what you did. You create logs, right? For instance, I mean, you create a change document. So you everything that you did, all the steps that you did, document it, right? The reason you document it is because you come back, let's say you do this on a Saturday, and you come back on a Monday, and then you realize you have too many calls to your IT and saying, no, something is not working. You can quickly go back to your Saturday's logs or documents and say, what did you do last? And you find that you made some changes, and you can assume that maybe the problem was because of that. So you try to analyze that, and you put that in your gathering facts, and you say, this is what I did on a Saturday, and this is, it comes in your facts gathering stage, right? Even another reason why you should document everything is maybe you're not there in office, you come back on Monday, the person who did on a Saturday, they documented whatever changes. You come back on a Monday, you can go back to their changes, what they've done, and then you can identify what the problem could be, right? So always have a documentation again. And then, of course, possibilities. When you're looking at solutions, you need to also look at your business goals. Like I mean, maybe a customer calls in and says, you know, they cannot access music sharing site, right? Now you need to look as an IT, you need to look at that. Does that need of the customer, they might say that's very important to them, but is it a business requirement, right? So you need to look at all those aspects, and different organizations have different business goals. You need to look at the business goal of your organization and try to align your problems and solutions according to your business goals, and try to make sure your business does not have any impact. If you think your problem that is there currently, if that's going to have a large business objective, I mean, if business disruption, you need to make sure that you need to escalate this. You need to keep your higher up managers in the loop. So all that decision you need to do, you need to decide if you should engage higher ups depending on the impact of the problem, right? So this is basically a troubleshooting methodology. Use this methodology to have a process of your resolution, right? So that's all we want to discuss today. Like I said, we are reaching the end of ICND1, and we are going through the topics of ICND1 and picking topics that we have not discussed and try to discuss, so that you have we will have touched all the topics on ICND1. Next video also we'll be going back and seeing what we have not covered, and we will cover. So I think by day 32 we should be done with ICND1, and you all could, if whoever is interested to write ICND1, can go ahead and write the ICND test, right? So thank you for joining us today. Stay tuned, we'll be back very, very soon.